Hello and welcome to C++ Weekly. I'm your host, Jason Turner. I'm available for code reviews, contracting, and on-site training. This episode, I'd like to bring up this little thing that I saw at Code Dive. They had t-shirts that looked like this. And it took my brain just a moment to parse it, but I thought it was an awful lot of fun, and so it's been on my to-do list for almost exactly a year now to show everyone here on my YouTube channel this little ditty and what exactly it means. We can break it down. Now, the short answer is that this is about one of the most complicated ways of doing nothing that I can think of. You can do lots of other things, of course, to do nothing, but it's a very succinctly complicated way of doing nothing. And you may or may not be surprised, depending on your experience with C++, to know that I can do this and it's still doing nothing and still compiling. And I can probably do that and it's still going to do nothing and still compile. And things start to get awfully weird here the more we play with this. But really, let's just remove this bit here. And what we have is a lambda. This is the part that is highlighted at the moment. The open brackets are open bracket, closed bracket is the lambda introducer. It is also where a capture would go. We have no capture. The parentheses are the list of parameters for the lambda. Now, in the case of a simple lambda, you can actually leave that off and we still get the same result. And then these braces are in fact the lambda body. So this is a lambda that takes no parameters, has no captures, returns nothing. Its return type is implicitly deduced as being void. And that is it. That is all we have is a lambda here. So I could do this, and again, it's going to have the exact same meaning that it did a moment ago. Now, this plus right here is where things start to get a little bit more interesting again, because this plus is invoking an explicit conversion from a captureless lambda to a function pointer. And then these parentheses here, this outermost grouping, is just saying this function pointer that I have just created, I now want to invoke it. So we're doing this immediately invoked function pointer that is from an explicit conversion from a captureless lambda to a function pointer, and then we're invoking it. Now, the reason this works is because you can reference or dereference a function pointer as many times as you want to, and you really get the same thing back. Technically, we overdid it there, didn't we? Technically, we are going back and forth between function pointer and function reference, but special rules, old school from C. Once we have a function pointer, we can do anything we want to with it, back and forth between a pointer and a reference, and it's still going to be invocable in the same way. Now, if we remove that plus, we still get the same thing back. So the compiler is still doing this conversion to a function pointer for us. So as always, we can take this kind of thing, and if we're interested, break it down in C++ Insights. Let's go ahead and make this nice and big. And let's see what happens, because I haven't actually done this yet. So it has declared this lambda for us. Okay, we see that. Now we are taking the lambda's call operator and doing a static cast to a function pointer. And then it has the plus outside of that. I would have thought the plus should go here. And then we see that we are calling this. Now, just out of curiosity, again, since I haven't actually played with this, what happens if we go ahead and add a few of these function pointers, references, and dereferences and see what happens? And so we don't get any more insight really here from C++ Insights as to what exactly happened, but that's what we've got. We've got a lambda that has been converted to a function pointer, and then we can do the things with it that we want to, and then invoke it. Just an interesting way of doing nothing. So thank you for watching this episode of C++ Weekly. I hope you enjoyed it, and I hope you learned something new.